Newton's laws. We've already discussed mass, time, length, position, displacement, velocity, speed, acceleration, net force. We've talked about Newton's first law, which is the law of inertia. States that an object that is at rest tends to stay at rest, or an object that is in motion in a straight line tends to stay in motion in that straight line unless acted upon by some external force. We've also talked about Newton's second law, which is the law of acceleration. In order for us to move that object that is at rest, or in order for us to stop or to further move that object that is in motion, we have to apply a force to that object. When we apply force to that object, we're going to accelerate it. Once we accelerate that object, it's either going to come to a stop, it's going to speed up, it's going to do something, it's going to move, okay? So, what are we talking about now? We talked about Newton's first law. Newton's second law. Now we're talking about Newton's third law. All right, here we go. Newton's third law has to do with this. Let's remember. Let's just say we have ourselves an object here. This object is on a plane. Okay, it's just resting. It's just sitting there. No one's bothering it. It's just fine by itself. Okay, so this is Newton's first law. Newton's first law said that that object is at rest. It tends to remain at rest unless we act upon it with some external force. So let's act upon it with some external force. We're going to call that force sigma F. It's going to represent the net force acting on this object that possesses a mass which is equal to m. As a result of this force acting on this mass, acting on this mass, we are going to have ourselves an acceleration. The representation, or our equation, our concept here is saying that the summation, or the net force, is equal to the product of the mass times acceleration. The acceleration will be in the same direction as the net force, as we can see by our arrows. Now, Newton's third law is the law of action, reaction. It's basically saying for every action that you make, if you apply a force to an object, that object is going to apply a force back on you that's equal and opposite. All right? So where is that occurring in this picture? We have a picture up here. We have the net force acting on the object. The net force acting on the object is going to produce this acceleration A. So where's that action reaction? Where's that reaction going to occur? Well, that reaction is going to occur here. Okay? And that reaction should be equal and opposite. Basically, we're saying that the net force, which is in green, is going to equal to the negative net force, which is in blue. So this is our statement. The net force is going to be equal to a negative net force. All right? That's what's happening at that interaction. So what's the idea? We're saying that this net force, which is in green, I should write it in green. This net force, which is in green, I should have a positive sign on this side. So that was incorrect. Statement. So the net force, which is in green, if I bring that blue over and I subtract this force, we should end up with 0. The forces are going to cancel out. Okay? That means that if I'm applying my finger to this mass, that means my finger's not going through that mass as though it was some foam, some soap foam or some powder. It's not going through that mass. It's actually balancing in that interaction. We need this. That's Newton's third law.